Hello and welcome to Flip. So today we are talking about oxides, and you can see that there are four kinds of oxides here: neutral, acidic, amphoteric, and basic. Okay, and they are packed under two different groups. One is non-metallic, one is metallic. Okay, let me tell you how to identify what's metallic and non-metallic first. You just have to look at the first atom, okay, of the molecule of interest. For example, for non-metallic, you can see that the first atom, okay, is carbon. Carbon is non-metallic, okay, so it belongs to a non-metallic oxide, which is neutral and acidic. On the other hand, if your first atom, okay, is a metal, zinc or magnesium, okay, it will be a metallic oxide, okay, and it's that simple. So first of all, I'm just going to say that neutral oxides, okay, are the simplest because they don't do anything. Neutral oxide do not react with water, do not react with acid, do not react with alkali. Okay, makes sense, right? Whereas for acidic, okay, they react with water and alkali. Makes sense, right? Because of neutralization. So acidic can react with alkaline solution. Let's look at basic. It can react with water and acidic. Okay, because neutralization again, basic can react with acid, but it cannot react with alkali because it doesn't make sense, right, for two alkali molecules to react. And so the same applies here. Acidic won't react with acid. Okay. Amphoteric is a special guy. Okay, it doesn't react with water, but it reacts with both acid and alkali. How do you remember this? Because amphoteric sounds like the word amphibian. And amphibian is an animal, okay, that's able to live in land and sea. Okay, so similarly for amphoteric, you can think of it as it can do both things. Okay, both extremes, which is acid and alkali. Okay, so amphoteric can react with both acid and alkali. Okay, so this is just a rough mind map for what's about to come next. We will go into details one by one. We'll begin with basic oxide. Okay, so basic oxides are really just group 1 and group 2 metals. Okay, so basically you can see that I have sodium oxide here. Sodium is from group 1. Magnesium is from group 2. Okay, and so when they react in air, okay, oxidized means they just are exposed to air. Okay, they form a basic oxide, okay, which is a metallic oxide. Then there are also solids at room temperature with high melting point and boiling point. So they are just solids, basically. Okay, most of them cannot react with water, but if they can, okay, this is what will happen. In the case of sodium oxide, you react with water, you'll just form a metal hydroxide. Okay, so how this works is really it's just balancing of equation. Okay, you can see that there are two molecules of Na here, and two, and how many? And two O's, OO, and two H's. Okay, HH. Okay, so it's quite simple. You just have to rearrange them, combine them together. Next is reaction with acid. Okay, because they are basic, okay, alkaline, they can react with acid, okay, because in neutralization. So what happens is as what we have seen in the previous video, okay, Mg will take Cl, okay, and form MgCl. Remaining, okay, will just form water. Okay, and this is neutralization. Okay, so that is all for basic oxide. Okay, so remember that in this chapter, okay, basic, acidic, and amphoteric each have only two reactions. Okay, let's move on to acidic next. So acidic is the same as basic in the sense that, okay, they are also formed when non-metals burn in oxygen. Okay, that means they oxidize in air. Okay, first reaction is the same as basic. They can react with water. Okay, so carbon dioxide in this case react with water to form a acid. Okay, so this is not an acid yet. Okay, when they are in oxide, their oxide form, okay, for example carbon dioxide, is not yet an acid. Only when it reacts with water, then it forms an acid. Okay, similarly just now, in the case of basic oxide, this is not an alkaline yet. When it reacts with water, then it can form an alkali. Okay, hopefully it makes sense. Okay, yep, so back to this acidic oxide. First, they can react with water to form this carbonic acid. Secondly, they can also react with alkali to form salt and water. So this is also neutralization. Okay. One thing to take note is you can see that I did not write metal oxide here. I wrote non-metallic oxide. Okay, just to make sure that it doesn't confuse you. Okay, so that is all for acidic oxide. You can just combine the number of atoms to get the products. Okay, just follow this formula and it should work all the time. Next is the special one that we saw just now. It's called amphoteric oxide. Okay, there are only 3 of them to remember in your syllabus. First one is zinc oxide, second, aluminium oxide, third, lead oxide. Okay, just remember these 3. The rest, there are obviously more in nature, but in your syllabus, just remember 3. Okay, there's only 3 for you to remember. Okay, how it works is really very simple. It's the same as how you would expect a base to react with an acid. Okay, it's also neutralization. Okay, you can see that the zinc here, okay, he takes in the Cl to form zinc chloride, and the remaining oxygen will form a bond with the 2 hydrogens to form water. This is also neutralization. Okay, if you react it with an alkali, you get so it's metal oxide plus alkali to give you salt and water. All these are neutralization. But you do not need to know any equation for the reaction with alkali, because this is out of your syllabus. As I mentioned in the previous video, alkali reactions are a bit special. So it's so special that you do not have to know in your syllabus, because it will be a bit confusing. Finally, it's a neutral oxide. So neutral oxide, like I said, they are useless because they do not dissolve, they do not react, they don't do anything, they just exist. Okay, for the purpose of this discussion. So there are a few examples: carbon monoxide, nitrogen oxide, and water molecule. Okay, so all these molecules, if you put them in water, put them in an environment with acid or base, no reaction happens. Okay, no reaction at all. So it's just usually it's either in a gas or liquid phase. It's rarely in solid phase. Okay, so there's no reaction here for neutral oxide. Okay, so once again, I want to end the video with this mind map here. Okay, hopefully it helps you in your revision for oxides. Okay, remember that each oxide only has 2 reactions. And that is all for oxides.